Equations, part 4. Example, solve for x. We give you the sine of x equals the negative square root of 3 divided by 2. So we're going to first just ignore this number 2 for a moment, and we're going to think about when does the sine of x equal negative square root of 3 over 2. So I have my unit circle here just to kind of help you make this go a little faster. Remember, the sine represents your y value on your unit circle. So we have that angle 5 pi over 3. Now, remember, this unit circle goes on forever, around and around and around 2 pi n. So I'm going to erase that for a minute just to make it a little bit messy. There is one other place in the first revolution that the sine is also negative square root of 3 over 2. So that's 4 pi over 3. So let's start with this angle right here. I'm just going to make this one in purple. Okay? So what we're going to do is we're going to set this 2x equal to 5 pi over 3. And then understand that this goes on forever. 2 pi, and then n is all the revolutions around. So we're going to solve this equation for x. So when you solve for x, you're going to divide both sides by 2. Now we have a fraction over here, 5/3. So instead of me dividing by 2, I'm just going to multiply by 1/2. And then the second piece, 2 pi n, I'm going to divide it by 2. So now we simplify this equation. X equals 5 pi over 6 plus, and I'm going to reduce this fraction by a 2. So we have pi n. Now, x equals 5 pi over 6. I'm going to change this second piece to have like denominators. So I'm going to change this to 6 pi over 6 n. So to find more angles, we're going to add 6 pi over 6 to the previous angle. So we have our 5 pi over 6. Now we're going to add 6 pi over 6, so that will give us 11 pi over 6. So I'm just going to cross it out here. Then I'm going to add another 6 pi over 6, so we get 17 pi over 6. Add another 6 pi over 6, gives us 23 pi over 6. Now we want to go to 2 pi. So 2 pi as a 6 is 24, 12 pi over 6. So we don't need to count these two right here. We're good to go. We just want that first revolution. Now again, remember, it does go on forever. Now, we haven't talked about this red value here. We're going to do the same exact thing, setting it equal to 4 pi over 3. So I say 4 pi over 3. Now remember, we can go around another revolution, another revolution, another revolution, which is 2 pi, and then n. So we're going to divide both sides by 2 to solve this for x. The first fraction, I'm going to multiply by 1/2. The second piece, I'm just going to divide it by 2. So x equals 4 pi. 3 times 2 is 6. I'm going to reduce these 2's. Pi n. And now 4 pi over 6 reduces to 2 pi over 3. Now I want this piece right here to be the same denominator, so I'm going to increase this by 3. I'm going to increase that by 3. So to find more angles in that first revolution, I'm going to add 3 pi over 3. So 2 pi over 3 plus 3 pi over 3 is 5 pi over 3. Then we add 3 more and we get 8 pi over 3. Now, let's think about 2 pi equals 6 pi over 3. So we don't need this 8 pi over 3. So we're going to go ahead and stop there. So we have 4 solutions. We have these two up here. to our 5 pi over 3. And then we have these two here when we set it equal to our 4 pi over 3. So that's our final answer when we increase this. Now sometimes this number might be a 3, sometimes it could be a 4. It doesn't change it too much from the process that we're going through.